Hello, I'm Kevin, VK6 Lima Whiskey and Victor Kilo 6 Tango in most contests. Now you've probably heard of the extended double ZEP antenna, and in fact you may have used this antenna. It's quite a neat idea, single wire antenna, and you get a few dBs gain over a dipole. So I was interested to find out whether or not I could get more gain from the EDZ, and with a little bit of modelling, this is what I've come up with. These dimensions are scaled for 10 metres. And we have a double extended double ZEP. So the antenna is a little bit longer than the standard EDZ, and we have some phasing stubs here, which are really important for maintaining the current maximum in the correct places so that we get the best gain possible. And the antenna spans 29.5 meters. So just a single wire, but with these phasing stubs. And we get a little bit more gain, as you will see shortly. These open wire line phasing stubs you can see there in the closed position, and this is a low impedance feed point here, fairly standard open wire line with the low impedance feed point. 11 meters high above ground level, that's optimum, but if you can only manage 6.5 meters, this antenna will still work. At 6.5 meters you get more or less the same amount of gain, but the elevation angle of the main lobe of course is a bit higher, whereas at 11 meters the elevation will be lower, as you will see shortly. So let's just take a look at the gain here. So we've got a very healthy 14.2 dBi at 14 degrees elevation, which is great. I mean, 14.2 dBi is consistent with maybe a 3-element quad or 4-element beam. It's very nice, especially from a single wire antenna. These secondary lobes here are also quite useful around about 45 degrees. And this is with the antenna at 11 meters height with a flat top. So there is a trade-off here, and the trade-off is in the beam width. So you can see here the beam width is quite narrow, so about 18 degrees. But it's got good side rejection here. So if you can orient this antenna to your favoured direction, then this will work very well, and you're going to get some rejection off the sides, albeit it's bi-directional. If you mount another antenna at right angles or at 45 degrees, then you'll also open up some other directions which might be useful to you. So 14.2 dBi is a very good gain for a single wire antenna. If we take a look at the feed arrangement here, we've got the 40mm spacing, 2mm diameter wire, common mode choke, 50 ohm to shack. So the common mode choke can be around about 7 or 8 turns of RG213 or RG58 on around about 100mm diameter PVC pipe. That will suffice for 10 meters. Alternatively, you can have a look at a W1JR style balun, 1-to-1 common mode choke on an FT240-43 ferrite core, 10 turns, and this is also a very efficient method to create a 1-to-1 balun with some common mode choking. So I can recommend this one. If you're running up to 500 watts, probably a single core will do it. Over 500 watts, I'd probably stack 2 cores and just wind the Teflon coaxial cable in the same manner. Teflon coaxial cable, I quite like that. It will take a little bit of power. It's very tough. So I've built quite a few baluns and various other matching devices with that Teflon coaxial cable. Now, if you want to use this antenna in other directions, there's a really simple way to do it. And you can see here we've got a cloverleaf pattern. So that cloverleaf pattern is made by changing these stubs. So instead of having the stubs closed, we open the stubs up with some relays. Open both these stubs up. We still feed it in the center here. Open these stubs, and then we get this nice pattern. Now, okay, the gain is reduced down to 8.7 dBi, but you've got obviously a different pattern altogether. It helps to fill in the gaps. So your maximum gain would be in this plane here, and then we've got the alternate pattern of a cloverleaf style. Now, this inevitably changes the feed point impedance, so you need to do something about that. So we can have a simple sort of LC match here. This sort of arrangement will bring the SWR back down under 2-to-1 over 500 kilohertz at the bottom end of 10 meters. So there's really not too much of a problem with this. This is very simple to implement. Common mode choke, well, this is exactly the same arrangement I've just been describing. So this is something that will work quite well. Now, obviously with this arrangement here and this arrangement here, we could take the open wire line all the way back to the shack and use an ATU in the shack to provide the match. So that's definitely a possibility. And one thing that then does, it opens up this antenna for use on all bands from 80 meters through to 6 meters. You will get some sort of match. You'll get various patterns. You get various elevation angles, but it will work on all those bands if you take this open wire line back to the shack. So there's a couple of sort of hybrid solutions with that. You could run this coax or you could run the open wire line down to ground level and then run coax all the way back to the shack. That's a sort of hybrid solution. And at ground level, you have an automatic ATU. That can kind of work as well. But it's always useful to think about whether or not you might want to use this on other bands. So open wire line back to the shack probably gives you the most amount of flexibility, I would say. Okay, so we've taken a look now at the double EDZ and what we can do with the pattern and changing the pattern and the matching. And now we move on to the next level, which is to try and get yet more gain from this antenna. So if we stack the antennas one above another, the height here is 12.73 for the top, 6.69 for the bottom one, and we feed it with 50 ohm coax here. Both these blue lines are the same length. Doesn't matter what length they are, just make them the same length. Common mode chokes, well, we've covered that previously. And then we connect both ends of these 50 ohm coaxial cables to quarter wavelength RG11 75 ohm coax cable. The end result is 50 ohms here, back to the shack. So that's a nice low impedance way to stack this antenna. And this is quite achievable. It's all in the same plane. It's only 12.73 to the top and 6.69 to the bottom. If you could only manage 10 or 11 meters to the top here, as long as you maintain this relative spacing here, the difference is probably going to be less than 1 dB. So these are optimum heights that I'm specifying here. Again, all the dimensions in millimeters. There is another way to feed this, and this is to take the feed point from the center. So this is open wire line in phase, and there's a low impedance feed point here, right in the center of the antenna. 50, 70 ohm, 75 ohm coaxial cable. Again, with a common mode choke at this point, back to the radio, or open wire line all the way back to the radio. And again, it then gives you the flexibility to use this antenna on all bands. And if you then open up each one of these phasing lines with relays, you will get the same cloverleaf pattern that I described before, but instead of getting 8.7 dBi, you'll get something like 11 dBi gain out of a cloverleaf pattern at a fairly low angle at around about 14 degrees. So 11 dBi is consistent with maybe a 2-element beam, but you've got 4 directions, and you don't need a rotator. So really a very useful antenna if you can build this stacked DEDZ. So let's just have a look at the gain here. So the gain's pretty impressive, 17.6 dBi. For a wire antenna in a single plane, that's a great gain figure. And it's around about 14 degrees above the horizon. All these plots are modelled over average ground. So there's a degree of ground reflection involved in these figures, obviously. But it's just modelled over average ground. If you model it over very good ground, you get a slightly better figure here. If you model it over poor ground, the figure may go down a bit, but really it's not going to make that much difference. The nice thing about stacking the antenna is you get rid of the high angle gain here. So this could be an interesting antenna. If you can't put a beam up, if you can't put a tower up, but you can maybe get some masts up, orientate this in the correct direction, then you may have an antenna that will really give you a great signal, a great DX signal that probably wouldn't be possible without towers or beams or other structures that might not be acceptable at your QDH. Okay, 73s for now from me, Kevin, VK6 Lima Whiskey.